Okay, so this is the third video for this week, and we're looking at equations involving brackets. So we've got an example here, okay, where we've only got x on one side, but there's a bracket involved. So it's just about how we attempt those. So there are, if we look at the balancing method to start with, there are two ways we can think about the balancing method. So I want to go through both of those, and then you can just decide which way you would tend to go. So what most people tend to do is they look at the bracket and they want to multiply the bracket out. So we'll start with that one because that's absolutely fine. We could multiply the bracket, so 3 times 2x would be 6x, and 3 times 1 would give me 3. So all I've done is expand that bracket. I've done nothing to the right hand side, okay, because I've not added or subtracted anything here. I have just changed what this looks like, okay, and this is identical to this, okay, so it's still balanced, okay. Then I would carry on solving like we've done up to now. I would want to get rid of this plus 3, so to cancel the plus 3 and get it down to 0, I need to subtract 3, but to balance that out I need to do that to both sides. So I've got subtract 3, subtract 3. So we've got 6x, and we're not adding or subtracting anything, so it stays as 6x. 3 take away 3 goes to 0, and 21 take away 3 goes to 18. So I'm left with 6x equals 18. And then I need to recognise that we need to divide both sides by 6, so I can find out what 1x is. Okay, so I do 6x divided by 6, 18 divided by 6. Okay, I'll get rid of this now, and we get x equals 3. 6x divided by 6 is just x, and 18 divided by 6 is 3. So that's the answer. Okay, so that's one balancing method, okay, which starts with multiplying out the brackets. But we don't have to start with multiplying out the brackets. Okay, so if we start with the same example here, okay, what I can see is I had 2x plus 1 and I had 3 lots of it. Okay, so I can divide by 3, but again, if I divide by 3, I need to do it to both sides. So we start by dividing by 3, and that cancels that, and 21 divided by 3. So when we divide by 3, I'm just left with 2x plus 1, and on this side, 21 divided by 3 is 7. Okay, this might make more sense when you see the picture, okay, but then again, as we did before, I would want to remove that plus 1, so I need to take away 1 from both sides to balance out, so I end up with 2x equals 6, and then I would divide both sides by 2, okay, so 2x divided by 2 gives me x, and 6 divided by 2 gives me 3. So we've got exactly the same answer, just by going a different way. Okay, so with our bar modelling method, okay, look at here, it might just help explain this method a little bit better. Okay, so we start with 2x plus 1, so I've got 2 x's here and a 1 at the end, okay, but what this says is I've got that 3 times. So what I've got here, I could put them end to end. I don't know if I'm going to be able to fit them, but let me put them up here, so then I can fit them up there. Okay, so we've got 3 times, I've got 2x plus 1, which is what that says. Okay, so this is one way to think about it. Now I know that that whole thing, 2x plus 1 3 times, adds up to 21. So this whole thing here is worth 21. Okay, but I also know, oops, my 21 in. I also know that I can split that into 3. Okay, because I've got the same thing 3 times. So I can work out 21 divided by 3, that each part here is worth 7. So from there to there is worth 7, and the same for all of them. So we get from there to there is worth 7, and similarly here, there to there is worth 7. Okay, and then we do what we did before. If that whole thing is worth 7, I can take 1 off here, which tells me the 2x's are worth 6, And if two x's are worth 6, they must be worth 3 each, so x equals 3. Okay, so you might want to sort of start with bar modelling and then use that to help you do the balancing, or you might just want to do the bar modelling, but make sure you show me those workings if you're going to do it. Okay, any of these techniques is absolutely fine. All right, so let's have a look at another example. So this time we've got 3x minus 2 that we're looking at. So exactly as we did before, we're going to start by looking at multiplying the equation out, multiplying the brackets out. So we've got 2 times 3x is 6x, and 2 times negative 2 is negative 4. Oh, it's down here. Okay, so we've got 6x minus 4 equals 32. So once I've got it to this point, it's similar to what we did before. I want to get rid of this negative 4, so I'm going to add 4 to both sides. Okay, which means these will cancel and I'm just left with 6x, and on this side I've got 36. So I've got 6x equals 36. But then I want to divide both sides by 6. So 6x divided by 6 gives me x. 36 divided by 6 gives me 6. So the answer is x equals 6. Okay. Let's do it the other way. So exactly the same equation. Okay. But this time I'm going to start by not multiplying out, but dividing both sides by 2. So I can divide by 2 to get rid of this 2, but to balance I must do it to both sides. So here we have divide by 2 on here, divide by 2 on here, which means on this side I'd be left with 3x minus 2. And on this side 32 divided by 2 is 16. And then as we did before, I want to get rid of this minus 2, so I'm going to add 2 to both sides. So add 2 cancels that out. 16 add 2 is 18, so we're left with 3x on this side equals 18. We're going to divide both sides by 3 this time. So 3x divided by 3 will give me x. 18 divided by 3 gives me x equals 6. Okay, so again, exactly the same answer. So let's see how that would work with bar modelling. Okay, so I've got 3x's here. Okay, and I know when I subtract, we've got to do 3x minus 2. So I'm not going to go the whole length. Okay, I'm only going to go up to there. Let's put a sort of line there. And the bit that's missing here is 2. Okay. Now, I've got that as 3x minus 2, but I know I've got that twice. So if I just move that move that down, I've got the same thing twice. Let's see if I can just copy that down. Let's copy that. So we've got not quite. Okay. Okay. So what I'm interested in is 3x, but 2 less than 3x, so not quite the same length as 3x, and I've got that twice. Now I know that those 2 lengths there, okay, add up to 32. So again, I could put them end to end. Okay, actually no, I'll leave it like this, makes it look slightly easier. These 2 lengths here add up to 32, so I know, because I've got 2 of them, each one must add up to 16, because 16 and 16 is 32. Now I know, I've got this 2 on the end, I can find that 16 add 2 is 18, so that whole thing there must be worth 18. Okay. And then, therefore, to find each x, I would need to divide 18 by 3 to give me x equals 6 again. Okay, and you can check this out. You can say, well, 6 add 6 add 6 is 18. Take off 2, because it was 3x minus 2, gives me 16. And 2 times that, 16 and 16 is 32, so we know it works. So, work through those examples. Have a go at these questions. make sure you show your working, whether that's bar modelling or balancing, and press pause, and I will reveal the answers in a minute. Here we go. So you should have x equals 6, x equals 4, x equals 11. And then for D, x equals 4, E, x equals -1, and F, x equals -2. Okay, so you've had a chance to practice all three methods. What I'd like you to do now is the assessment on MathsWatch, so that I can check whether you've understood what's going on. If you have any problems with any of these, then let me know, and if you have a problem with MathsWatch, let me know, and I'll try and do a video just to give you a hint as to how to start, or any mistakes you might have made. Okay? But as before, it's really important you show your workings, because that just helps me to help you if I can see where you've gone wrong. Okay, have a good week and have a good half term.